Welcome to section 5.6, part 2. This is the 60th session of the ISACA CISA exam prep series. This part picks up where the last one left off. In this session, we'll see how cryptography is applied in the real world. We'll answer several questions. How do you combine symmetric and asymmetric encryption? What protocols secure web traffic and network connections? How does Kerberos handle authentication? How do you secure email? And what does an encryption audit check? Why does this matter beyond the exam? Because the theory only counts when it's deployed correctly. Picture an online retailer processing thousands of card payments an hour. Behind every transaction sits a protocol doing the cryptographic work. If it's misconfigured or outdated, the data is exposed. As an auditor, you check the right protocols are in place and well managed. Let's start by combining strengths. Why mix symmetric and asymmetric encryption? Because each solves the other's weakness. The trick is elegant. Encrypt the data with a fast symmetric key, then encrypt that key using asymmetric encryption for safe delivery. You get the speed of symmetric and the easy key distribution of asymmetric. When you wrap a message and its encrypted key together, that's a digital envelope. A well-known privacy tool works exactly this way. This combined approach powers the protocols you use daily. What is transport layer security? It's the protocol that secures communication on the internet. It's what turns ordinary web browsing into the secure version. It works in phases. First, the client and server negotiate which algorithms to use. Then they exchange keys and authenticate. Then they encrypt the actual traffic. It uses two protocols, a handshake to set up and a record protocol to carry data. One audit note. It replaced an older protocol that had a serious flaw, so when someone mentions that old name, check whether they really mean it. Another protocol secures the network layer. What is Internet Protocol security? It secures communication between hosts and builds virtual private networks. It has two modes. Transport mode encrypts just the data portion. Tunnel mode encrypts the data and its header. To set up a connection, the two sides establish a security association. That defines the agreed algorithms, keys, and parameters. Key management here is automated using asymmetric cryptography. Now a classic authentication system. What is Kerberos? It's a ticket-based authentication mechanism using a trusted third party. It provides single sign-on while protecting login credentials. Think of it like a theme park. You prove your identity once at the gate, then you get a ticket that lets you onto each ride without proving yourself again. Its big advantage is end-to-end protection against eavesdropping and replay attacks. Let's cover a few more secure protocols. What is Secure Shell? It gives you an encrypted command line session to a remote system. It replaced an older tool that sent passwords in the clear. Best practices include changing the default port, disabling root login, and rotating keys. What about the domain name system? By default, it's insecure, with no protection at all. Its security extensions add digital signatures to verify a domain's authenticity. That prevents attacks like cache poisoning, where a user is sent to a fake site. But be aware, it can also amplify denial of service attacks. Now to a top attack target. Why does email need special security? Because it's the primary way attackers get in. Know the common attacks. Bombing floods an inbox with identical messages. Spamming sends unwanted bulk email. Spoofing makes a message look like it came from someone else. And business email compromise tricks an employee into wiring money. How do you defend email? With layered controls. Spam filters and antivirus screening. Email encryption so intercepted messages stay unreadable. A secure email gateway to filter unwanted traffic. and attachment control so users see file types before opening. Several standards add signatures and encryption to email itself. Finally, the auditor's checklist. What does an encryption audit examine? Several areas. Governance, like written policies, data classification, and separation of duties. Design, like whether the chosen algorithm gives adequate protection. Key management, the heart of it all. You verify how keys are created, distributed, rotated, and destroyed. And you confirm users and operators don't handle the keys directly. One sharp rule for signatures. Private keys should never be backed up, because that increases exposure. So let's bring it together. Combining symmetric and asymmetric gives speed and safe key delivery. Transport layer security and internet protocol security protect traffic in transit. Kerberos authenticates once and issues tickets. Email needs layered defenses because it's the favorite way in. And an encryption audit lives or dies on key management. Tie the theory to these tools and you can assess real-world cryptography with confidence. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.